Good afternoon, everyone, at least here in Italy. Good morning in Chile, I guess. So my name is Hagen Lehmann. I'm working at the university in Macerata in Italy. And my fields of research are social robotics, robot-assisted therapy, and an active robot-assisted didactics. In my talk today, I will give an overview about the use of social robots in an active approach to didactics, both on an individual level, for example, for children with special needs, but also on a group level, for example, in classrooms or in lecture halls. So let's start with a very brief introduction into what an active didactics is. The active didactics approach sees learning, the learning situation as a complex, multidimensional system in which every interaction between the different parts, changes not only the dynamics of the system, but also the parts. So this is very much based on ideas from the active approach to cognition, which is inherently interdisciplinary, as is the active approach to didactics. Basically, an active approach to cognition is based on the ideas from Varela, Thompson, and Roche, but has, of course, its roots also in ideas from early cybernetic research, Warren McCulloch, Heinz von Förster, Norbert Wiener, and von Glasersfeld's ideas of radical constructivism, but also on the autopoietic cognitive biology from Varela and Maturana. And one of the key points of the active approach is that it discards the distinction between internal and external factors influencing the development of a system that exists in an environment. And it replaces this distinction of internal and external with the concept of structural coupling between the system and its environment. So this structural coupling is defined as a continuous mutual process that co-transforms the patterns of activity of the system and its environment through the expression of reactions that are intended to maintain or reestablish internal equilibria. The individual agents or parts of the system change its environment, and the interaction process it interacts with the environment. And in this way, the system and the environment need to be thought of as two aspects of the same process. So this sounds a bit complicated, but translated into the active didactics approach, this means that knowledge does not exist in the student a priori. It is something that needs to be transmitted from the teacher to the student, but that it is constructed, that the new knowledge is constructed during the interaction between different individuals, in our case, between the students and the teacher. So this is a very important shift. The role of the teacher in this approach is to raise the awareness of a problem in the students, and after having done this, only then it becomes possible to find in the next step the solution of the problem together. The way this solution is constructed is, of course, determined by the teacher, who acts as a social mediator, as a mediator between the world that is experienced by the student and the knowledge that is constructed. And this process serves to activate the cognitive conflict in the students that connects the student's knowledge, the knowledge that the student bring into the process with the new problem and the related new to be constructed knowledge. It's very crucial in this process to validate the constructed knowledge. And for this, we need feedback. Feedback is the central part in this process, the feedback about the progress of the learning cycle. If we don't have feedback, we create a closed loop, a closed system, and self-referentiality, and the students don't learn. Basically, The problem a lot of teaching situations have, a limitation a lot of teaching situations have, many interactive processes, is a lack of space, of resources for feedback because of time constraints, because of willingness of the people to talk to each other. You can imagine also from your own experience, lack of feedback about ideas, lack of wanting to discuss things. And we think that the presence of an enforced embodied feedback channel in form of an embodied social evocative technology could become a fundamental support in the learning processes. And in fact, social robotics research aims at exactly this. It aims at providing such embodied feedback in form of social robots, social evocative robots, by introducing them into mixed human-robot environments, where the robots will interact with the humans in close physical proximity, which is very different to the usual industrial robots people were used to until even 15, 20 years ago, where basically the terms of interaction were determined by what the robot wanted to do, and not by what the human wanted to do. So social robots are basically dealing with the human interlocutors on human terms. There are a lot of different possibilities we have now due to the development of technology, how these robots could look like and what functions and what roles they could have. We can imagine they look human-like, zoomorphic, they can look cartoon-like, they can act as a partner, they can act as a teacher in ways of teaching, in didactics, they can act as a tutor for the students, they can act as a peer to the students, but also as a novice to incite students to teach something to the robot. So this is all very, very interesting. In general, the form and the behavior of the robot is determined by the function and by the situation the robot is going to be used in. And in our case, if we want to teach things to students, if we want to construct new knowledge, it stands to reason to use a robotic embodiment that is capable to communicate with humans on human terms, non-verbally and verbally. And therefore, a lot of these robots that are used in situations, in teaching situations, are humanoid or semi-humanoid. But this is not only an advantage, this is also a problem. Because if you have a humanoid robot, a robot that looks like a human and has features that are similar to a human, people expect it to behave like a human. If the robot does not behave like a human or looks too much like a human and doesn't adhere to the expectancies of the human, it will fall into what's called in social robotics the uncanny valley, which basically says that to a certain point of human likeness, people will like the robot, but if it becomes too human-like, but not just human-like, they will find it creepy and repulsive, and they will stop interacting with this technology. And one of the central reasons for this has been found, has to do with the behaviors of the robot. So if the robot has, for example, a head, hands, arms, eyes, people expect these parts to move like they would move in a human interaction. And if they don't, then people don't want to interact. So this is very, very interesting. For example, I have here an example of the ICAP robot from the Italian Institute of Technology. And this robot has eyelids. So people, of course, if they see eyelids on the robot, want the robot to blink. So if the robot would stare only at the people, people don't like this. Or if it would blink randomly, like in this fashion, you would go pop, 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 pop. People would think the robot is nervous. So we implemented a naturalistic blinking behavior that is based on physiological data from humans, for example. So you can see here, the robot blinks before it starts to talk, after it starts to talk, it does double blinks, it blinks in the right moments.
And the human asks me, where is the octopus? I then point to one of the objects that resembles an octopus and say, I think
this is about the game we used to play with the robot.
Do you actually understand what is asked of you?
Well,
So we showed these kind of behaviors to human participants, and these human participants then said that, or we used three different conditions. One was random blinking, one was blinking, staring, not blinking, and one was blinking in the fashion of a human. And it was very obvious that people prefer to interact with the robot that was not staring at them. Okay, so this only to serve as an example what kind of problems social robotics is still dealing with if we use humanoid robotic platforms. Okay, so to sum up, the goals of social robotics is that untrained humans can communicate and interact successfully with robots in complex social environments, which is even for humans in some situations difficult. And that this interaction is intuitive, flexible, and pleasant. This is very important. We don't want to make people feel bad when they interact with the technology. And besides the problem of the uncanny valley, we also have a lot of other issues that need to be solved. So we're still dealing with technical and conceptual limitations. Technical limitations, the foremost of all is inappropriate feedback from the robot. So, and this is based to perception issues. The robot needs to identify humans. It needs to identify when it is addressed, from whom it is addressed. If it's a group situation, it can recognize a face, but then it is the difficulty who of the 5 people in front of it wants to talk to it. It needs to understand ideally the goals and the intention of the person that is talking to the robot, and then behave accordingly. And the communication, this behavior needs to be not only verbal, but also non-verbal and coordinated. All parts of the robot and the interaction process needs to be coordinated. So it's not only that the individual, within the individual, the behaviors need to be coordinated, but also between the individuals, the interaction process needs to be coordinated. And at the current state, this is still difficult. However, there are different fields in which these robots are used. They're starting to show up more as home companions. Here they help to counter effects of loneliness for elderly people, or the mediation in human-human interaction, but this is still very early developments, and there are not many commercial products out there yet. And a field that is where robots have been more implemented is robots for education, of course, entertainment robots in shopping malls and banks and so on, and robots in robot-assisted therapy. And I will give you an example from robot-assisted therapy and one from robots in education. So let's start with robot-assisted therapy. Here you have some examples of robotic embodiments that have been used in therapy for children, for example, with autism spectrum disorder or ADHD, or also Down syndrome. In the center of this, you see the Casper robot. Casper robot is an embodiment that was developed by the University of Hertfordshire. I have worked in this project for 5 years, and the idea here was to use the robot as a social mediator in games for children with special needs, or specifically for children with ASD and other comorbidity problems they had, like ADHD or others. Since we were doing this research in schools for children with special needs in the UK, we also tested the robot with children with Down syndrome, for example. And what we would usually do is to use the robot in play scenarios in which the robot would function as a mediator between the teacher and the child. So there would usually be individual or dyadic interactions. The robot would basically be integrated in different types of games. In imitation games, in which the child was asked to imitate what the robot was doing. So basically we could help the children to teach the location, the position of their body parts, teach them where is left and where is right. We could use the robot, or we use the robot in turn-taking games to teach the children to wait in collaborative games for their turn, which is a very important social skill. A lot of these children are missing or having problems with. And also in cause and effect games, where the robot had artificial skin, so it has a tactile modality, and this tactile modality basically could be used via feedback to teach the children they shouldn't do this, they shouldn't do that. This creates a negative feeling and this creates a positive feeling. This is an example of such a setup. So the child, after various sessions, basically learn, oh, this might hurt the robot. So the robot gives, via this very simplistic negative feedback, the child learns that this is something it shouldn't do, and it knows exactly what it shouldn't do after. Poking in the eye or poking in the face, for example. So for a child that has very great difficulties in modulating the physical force it is using in the interaction with others, this is a great advantage, or this is a great success in the therapeutic process. Okay, so yes, so the robot, for example, says, this is nice, this is tickling me, or when you poke the robot, it says, ouch, you're hurting me. And it is very clear also from this video that the child, after a while, starts to do social referencing. Social referencing with the teacher who's in the room, also with the therapist who's in the room. So the robot really increases the reticular structure of the feedback, of the interaction between the child and its environment. Okay, so let's move on to the current research we're doing, which is concerned with using robots in an environment to increase the feedback structure in an environment where there are many students. This is not for children with special needs, but for university students, first and second year students of pedagogy and didactics. However, of course, we could use the robot applications also to increase the inclusion for students that, for example, because of physical constraints, cannot participate to the general lectures. We are using the robot here as a feedback device to basically provide structural support and also personal support between the teacher, the newly constructed knowledge, and the students. And this is done in a certain way. The robot has very many different applications in which it can integrate itself during the classroom. In the beginning of the lecture, the robot recapitulates what was done in the previous lecture. It gives also an overview of the lecture that is ongoing, and asks the students if they have any questions about certain key issues from the previous lecture. It structurally reminds the professor, since we have 3 hours lectures, that the professor has spoken, for example, for 50 minutes or 60 minutes, and that the students would need a break in order to focus again, to relax a second. And during these breaks, the robot would do certain relaxing activities, play music, do Tai Chi, or do a dance with the students, and also provide personal feedback on a questionnaire that is done in every lecture. So during the breaks, it would provide personal feedback based on the student ID number of a questionnaire that was done in the lecture before. in the previous lecture. So the students could go up during the break and then ask the robot, giving the robot the ID number, and then the robot would basically search for the answers the student has given in an audience response system, which is a Google server we are using, and then provide this kind of feedback. So this is good for the students to understand if there are problems with key concepts they have not understood, and it is good for the professor, because the professor can also look at these results and then understand which of the students has which problems or what kind of problems. During the ongoing lecture, the robot also provides feedback about the questionnaire, but in a general manner. So it basically calculates the percentage of the correct and wrong answers the students have given. And this can be used in the ongoing lecture with the professor to understand where are the problems in general of the class, and then address this together with the class. Again, reinforcing the feedback mechanisms in the learning process. And at the end, the robot provides a summary of the class and gives the outlook of the next class and asks if the students have questions that the professor then can answer. So if you want to see examples of our introductions or of our applications with the robot, we have a YouTube channel you can find here. It's called An Active Robot Assisted Didactics. And this is just the introduction of Pepper to the current year's lecture.
Buongiorno a tutti. Inizia oggi il corso di teorie e metodi della progettazione e valutazione scolastica.
So the robot, as you can see here, uses gestures to reinforce what it is saying. They are gestures that are internal to the robot, but we also created gestures that are context specific. This goes on for 5 minutes. I only wanted to show this video as an illustration for what has been done, but if you want to see more, please go to the YouTube channel. Of course, we asked our students how they feel about the different implementations of the robot, and the feedback was in general overwhelmingly positive, specifically concerning the feedback activities linked to the questionnaire. They really like this. And in the future, we are thinking about even creating more feedback channels, introducing them during the lesson so the robot can actively interrupt the lesson and provide structural feedback. Okay, just to give an outlook. Again, the goal is to always increase the network characteristics of feedback mechanisms during learning and teaching activities. And in this modality specifically, in our situation right now, social robots can potentially provide embodied feedback in situations where there is the need for reduced social contact, as in our current situation, or where the situation requires reduced social contact, like in a situation with children with autism spectrum disorder who are easily overwhelmed if there is too much social interaction going on. Okay, thank you very much for your attention.